morning, children. So today let us see what are the problems, how to solve the problems in human eye and colorful world. So let us start the session. So first problem is the in-text problem, page number 190. First, a person with a myopic eye cannot see objects beyond 1.2 meter distinctly. What should be the type of the corrective lens used to restore his proper vision? So he should use a concave lens to correct his defect. He should use a concave lens to correct his defect. So a concave lens will have the focal length will be in negative, and thus the power of the lens also will be in negative. So such a concave lens should be used to correct the myopic eye. So the next problem is, a person needs a lens of power minus 5.5 diopters for correcting his distant vision. For correcting his near vision, he needs a lens of power plus 1.5 diopters. What is the focal length of the lens required for correcting distant vision and near vision? So for correcting distant vision, he uses a power of lens. He uses the power of the lens. He uses a concave lens. Whose power is minus 5.5 diopters. So the focal length of such a lens will be F is equal to what? So 1 by P. F will be calculated as 1 by P, which is equal to 1 by minus 5.5 diopters. So minus 5.5 diopters, which is equal to 0.181 meters. So a focal length of minus 0.181 meter, the lens should be used to correct his distant vision. Next, to correct his near vision. What type of lens should be used? A convex lens. Should be used. What is the power of lens given here in the problem? The power of the lens is given as P is equal to 1.5 meters. So what will be the focal length? So the focal length F is calculated as 1 by P is equal to 1 by 1.5 meters, which is equal to 0.66 meters. So F is equal to 0.66 meters. So a convex lens of focal length 0.66 meters should be used to correct the hypermetropia or the near vision. Then next problem, the far point of a myopic person is 80 centimeter in front of the eye. What is the nature and power of the lens required to correct the problem? So first you should understand. See, the far point of a myopic person. So to correct myopia, we usually use concave lens. So how to calculate the focal length of this concave lens? lens will be calculated using the lens formula 1 by f is equal to 1 by v minus 1 by u. Now here, what is the image distance? Image distance of a myopic person V will be taken as his far point. The far point will be taken as the image distance. So what is the far point here? V is equal to minus 80 centimeter. Then what will be the object distance? What will be his object distance? So the object distance will be taken as infinity. The object distance u will be taken as minus infinity. So how will you calculate focal length? So 1 by f is equal to 1 by v minus 1 by u. In that way, 1 by f is equal to 1 by minus 80 centimeter minus infinity. So let this become 0. Now 1 by f is equal to 1 by minus 80. So f is equal to minus 80 centimeters. So accordingly, what will be the power of lens? 1 by f. So it is equal to 1 by minus 80 centimeters. Minus 80 centimeters. So to find power of the lens, you should use the meters. F should be expressed in meters. So converting this 80 centimeter into meters, you get the power of lens as minus 1.25 diopters. You should convert this as 100 by minus 80. So you will get the power of the lens as minus 1.25 diopters. So a concave lens